Hey everybody, let's go ahead and get started. Sorry I'm pretty late today. Had some extra errands to take care of and some unexpected family visiting, but it's okay. We'll just work with what time we have. So yesterday we finished up doing the terrain color map, or just terrain textures, and now we can see that we blend between two different colored checkerboards. And these checkerboards are separate images I can show right here. So I'm not cheating by drawing a simple checkerboard on there. I actually made these checkerboards like this so that we could make sure they line up, and they do. So mission accomplished there. Today we're going to work on, well, we probably won't get to it today, but our next big project is we want to do bump maps, which basically will deform the terrain here based on some image, so that I'm envisioning, like, say there was a big patch of sand here. If we wanted to have a dune image, then the bump map could cover over multiple tiles, and that's the reason why I'm going to go with a bump map instead of letting mod authors like give specific hexagon top models, for example. So that way the image can carry over multiple hexagons and they'll blend nicely when there's different tiles in the middle. That's my idea anyway. But we're not quite ready for that yet. Gotta do a little bit of cleanup. So oh hey Ice Boy, I'm doing pretty good. How are you tonight? So I investigated this a little bit because we were worried that the texture 2D array might be too small, and from my research, I don't think we really have to worry about this. According to Windows, the textures in Direct 3D 11 can have 2048 slices, which is way more than we'll need. Oh, thanks Ice Boy, I'm glad you think so. Yeah, I think it's finally starting to come together, at least to look like something nice. We've had the turns done for a while, so now we'll have it looking good too, I hope. But then this person says that in their Unity that the texture 2D array has a maximum size of 2 gigabytes. So let's see. If I pull out calculator, you can see our texture is 2048 times 2048 times 16, that's bytes, so just ask Google, because I'm too late for me to try and convert that to gigabytes. Bytes, gigabytes. Yeah, so that's so we can see that even if our texture is the maximum, like even if we take up 2 gigabytes here, we can still fit a lot of these textures in there, because that's like less than 1/20th, so we could fit about 32 textures. So we might just have like a hard limit of 32 on the game just to keep things from crashing, but I think that's fine. And then here people say that the maximum texture size dimensions is this, but then you can have almost unlimited array slices, so, or 64 there, so I think we'll be okay. That's a lot of gigabytes. Oh, I did see your map. It was good. Do I have any tips? I actually think they looked pretty good. I don't know. I mean, I don't know. In order to give you tips, I'd have to look more into the story or game design of your game, but I thought the maps themselves looked great, actually. But, so yeah, we can wait to take care of this. In fact, I'll mark this as done, and then just say... Well, we should probably test larger textures, but we'll just need to cap texture 2D array size at gigabytes, maybe max 32 textures. I'll have to do a little bit more research on that. No problem, Ice Boy. I actually like the art. I've always liked the art in RPG Maker. They've always had good artists. But anyway, back to this. Okay, so one other thing we want to do is allow mods to define this world position multiplier and the terrain shader. And if we pull up the shader, not here right now. Trying to figure out where the shaders are saved. Right here. That's fine. So we have this multiplier right here, and I'd like mods to be able to change that. Look at the game now. And so just kind of try to remember how many squares were in each hexagon, about 2. And then if we change this to 0.01, you can see that squares change size, and I think that mod should be able to change that resolution. Yeah, so now they're about size of a hexagon. So I think one way we can do this is by just giving another property up here. Call it terrain stretch. Be the terrain texture stretch, all that, and it's from a range, I don't know, let's say like 0.001 to 10 or something. And the default will be 0.02. Then all we have to do to use that is declare the variable here with the same name. And a half in shader code is the same as... Oh no, it's not exactly the same as a float. That might not be enough precision actually, so I'll upgrade this to a float. Okay, and now we just change that. Hopefully we won't get any errors. Error in terrain at line 9. Oh, the parenthesis at the end isn't needed. I think it's happy now. So let's look at the terrain. Material is what I want. Okay, that's not what I was expecting. When I click on the mesh, there must be a problem with it must not have compiled correctly or something, but it's not showing an error. Let me just change again, and if it compiles. Let's just press play and see what happens. I think it'll just be a pink brain, because yeah, something's wrong with this shader, but it's not giving me an error. Let's take this out again. Because obviously I messed something up. Probably used the wrong data type. Now it's back. Yeah, you can make these floats. I'm not sure. Not the. I must just have to use the half type here, but I feel like that's not going to be enough precision. Let's just try that and see what happens. Took another slider. Oh, I didn't save it. Okay. Unexpected. Oh, I'm missing the parenthesis there. Okay. Yeah, now it's working. But okay, there it goes. Yeah, so it doesn't have a ton of precision. Wonder if instead of multiplying, if we should divide. That'll probably be slower. Well, let me do this float, I wonder. Okay, yeah, when I did that, it seemed to... I don't know, it's still not the greatest slider, isn't anyway, but we can they'll put whatever values here we want. So the larger the value, I think that the smaller these squares will be. Put something like half. Interesting. Is it? Oh, I think, yeah, I forgot to actually put this variable here. Because I was waiting to make sure that the GUI updated. Okay. Now let's try this again. If I go 0, 0, or 0, 3, you can see how the squares look. Yeah, so they're smaller. So the bigger the value here, the smaller the texture is on the hexagon. Yeah, so now you can barely even see it. We'll go back to O2 just for now. But actually we need to make this settable by the shader, or by the mods, so while we're there, we might as well add in some other values I know that we'll need for the bump maps. So one thing we're going to be doing here is we want to basically the bump map will take samples in a square pattern, but then it'll also offset every other by like half. Yeah, that's not a good explanation, but why is it doing that? Oh, it has a stroke. That looks better, and let's make blue. So let's say if we take a sample here, then we take another one halfway, and this is where we would sample the bump map to see whether we want to move this point up or down to make it 3D. And so for the next one, we'd want to sample it like half offset like that, so that way they're not just perfect squares. And so we should also let the mods decide on the spacing here. But one thing that might be a little difficult is I kind of want these to be even based on like the world coordinates. So say for example, it's going to be hard to do it in Inkscape, I think. But these lines, not what I wanted. These lines might not always line up perfectly with the edges of the hexagon. So we're going to have to do quite a bit of math. But anyway, this interval, I think the mod should be able to decide. But maybe I'm getting ahead of myself making it editable right now, because I guess we should see if we can even support that in a good way. But yeah, let's go ahead and add in the texture resolution that or texture multiplier that I just created in the shader. So go to the table of contents. Trying to decide if like this information should be stored in another object, but I don't know. I think it's okay. Let's call this the word texture. I guess stretch, that's what we called it before. Now, store that somewhere in the game data. I guess we can just do it in the board metrics. This will just be the shader stretch value. And last part, I guess not the last part because we have to actually set this in the shader, but when we're loading all the assets, we'll want to store that here as well. Not in block organizer, it should be wherever you do the other metrics. So let's see, this will be extra stretch value and put that there. And then we want to make sure that this is greater than 0. So if it's less than or equal to 0, and let's do like some small number. So add board color texture stretch value. We'll just leave it at that for now. And I guess I should need to set that here. And let's set it to something different now, just so that we can tell it's loaded. And oh, one last thing. Here in the play link where we actually hook up everything to the material, we also need to that here. So terrain material, that float. And the name is the, let's have to look in the terrain shader, and that's this terrain stretch. And the value is in the database metrics, stretch value, and so that should take care of everything. And I'll just go ahead and press play, and we should see really small texture because I set it to 1/2 in the mods. And we can see here, by default, it's 0.02, so if it gets changed, then we know that the mod did it, and it does, so we're good to go. I'm going to set this back to more sane value so we can actually see the textures. And good, it looks fine. And now we're done with that, and we can change this, or mark that as complete. The next we'll move on to the height maps, or bump maps as I've been calling them. I guess height maps is more technically the right name because bump maps is something else, which we won't actually be doing, but just used to calling it things like this bump maps, but I guess I shouldn't. Let's see. So first of all, I'm just going to try and, well, I guess we need to have this value. I'll set this in the board metrics. Floats. So height, sample length. In fact, I can just call it the sample length because if we do other textures, and it's the same thing. This is just where we're going to create a new vertex. And fortunately, it's going to ruin a lot of our really nice, not really ruin, but our very simple blending, because right now, if you look at our mesh, every time it blends right now, we only just set the actual textures here and then the game will blend for us perfectly, but in the future we might have like a bump vertice right here, and so we need to figure out the exact blending between those positions at that point. Which, I mean, it's not that difficult because it's just linear over these. I'm actually looking. Yeah, that was a collision collision mesh, which is slightly different. So change this to wireframe or shaded wireframe. Yeah, so it's the same thing. We might have a point right here, and so we know it's just linear between these two. So it's not that difficult. It's a little more difficult on the triangles here because it's going between three, but you can still figure it out. It's just a shame that we can't let the shader do it. We have to do it ourselves, but the nature of adding more vertices. And I think this 3D look is going to be really nice, so. Right now it's really plain. Another way, I wonder if we could get away with just doing like, if we could keep the kind of hexagon look and then just break up the faces of the hexagons instead of trying to do a checkerboard grid. So let's see. Do the same type of thing. And draw it again. So we'll have this point in the middle, which would be a sample, and then basically we just have samples along each of the hexagon spokes at certain distances as defined by the mods. Might actually look better, and it's going to be way easier to for us to make. But I guess if we do that, like, thing is, the only problem is these bumps would be a lot more concentrated, excuse me, concentrated in the middle. Maybe we need to have like a weighted so that there's more towards the end, something like this. I don't know. I just can't have too many samples. And then we probably want to have some in the middle here too. That's not that difficult to do. Alright, so let's I think we'll try this just because it's simpler. Let's try to just subdivide based on the spokes first. So I'm gonna shrink all these just so that it's easier to work with. That middle are close enough. So I'm going to try to figure out how we'll need to make these triangles. Let's say we have 4 subdivisions, which will be fine. And then we want to have, I don't know, maybe 1 there and then 1 here. I guess we'd add 1 more subdivision every time it goes down, or maybe, actually we know we need a double, probably. So how would we... triangles? Probably not difficult. This is 1 triangle. Okay, we can actually just keep doing these pyramids. Yeah, this is pretty simple actually. That's okay. Yeah, then another pyramid. Okay, so that's not too bad. The winding is pretty... I'm going counterclockwise though. Then for the color, let's say these were on the excuse me, these were on the margin. Then all we'd have to do is just calculate the distance from the radius of any of these points, and then that would be, and then the difference from where the actual margin starts, which let's say is right here. And so then we know what percentage of the gradient has actually that doesn't make any sense actually, because the margin would bend right there. Let's say this is the margin start. Yes, then we know, I don't know, we're 10% into the margin, so that means we need to be 10% of our color into the other color. That's not difficult. Whereas if we try to do this with the squares, nothing would be actually on the hexagon spokes, so it'd be a lot harder to figure out the color at any point, and every hexagon wouldn't be regular. So I guess it depends on if we want to try to hide the hexagon structure or not, because this will definitely make it more obvious that the map's made of hexagons, but that might be okay. Yeah, so anyway, I'm going to try it this way first, and if it doesn't look good, we can always try the squares. Okay, so actually in the board metrics we don't want a sample length, we need like a subdivision number, so subdivision. I guess that's fine. So for example, I guess this one would have 2 subdivisions. Or 1. I guess we say it has 3 actually, because it's like 3 different rings. Like a bullseye, maybe that would make more sense. Call it something like that. Or even hex rings. So over here, this is 3 rings. So 1, 2, 3. Alright. Okay, so I'm not gonna pull that from the mods because it might change. So really all we have to do and again, I'm not gonna do the actual bumps right now, I'm just gonna try and make the geometry, and because the bumps will be the easy part really. Trying to think, let's take, I guess this will be a good one because it has slopes. So if we had 3 subdivisions right now, 1 there, what would almost be on the margin? How would we want to deal with that? Or that the margin and the subdivision should actually be, because this already doubles as one height vertices, so maybe the rings should only what am I trying to say? The ring should only be for this face, and then we'll have a separate count for the margin. That's what we'll have to do. The wrong file. So this is the face rings, and we'll want the hex margin ring. Or I guess I just call the face part just the hex, and then the margin is, because that's what I did here, the hex radius. So right now both have 0 rings. Well, that makes things a little simpler again, because now we don't have to try and coordinate making the hexagon and making the margin like I thought we might have to. Okay, so yeah, this is actually not that hard. So we'll still have just one center, and then we'd have something like, change this from I to C for corner. And for int R for ring. Are less than or equal to, yeah, because if the rings is set to 0, then we'd want to make the last one at least less than or equal to database metrics hex rings. Now this position is not just the corner point, it's actually an interpolation between the center and the corner based on some value given by the ring. And we'll also have to change the way those triangles are created. Because now we don't know. Oh no, we still know exactly what this number is. I don't know if it'd be easier to just use vertices count to start off. So first vertice is count 1. Well, I guess first let's find the position. So vector 3 position is vector 3 lerp, and that stands for linear interpolation, which basically, if you have 2 points in space, draw it better here. So if we have this line, and let's say we want to get something a third along the line, then that's what linear interpolation would do, given point A and point B, and then we pass in 1/3, and then it would give us this point right here. And so that's basically what we'll be doing to figure out these ring positions. And so point A, which is the start point, is the center point, and the end point is the corner point at position C, or index C. And now the value that we want to lerp at is given by this R variable, so let's see. So when R equals hex rings, we want to get 1, so I guess it would just be float R divided by the hex rings. But let's see. So if hex rings is 1, then that means that this would actually give us 0, so that's not going to work, is it? Because we actually want it to give us 1/2. So actually I think it's R plus 1 and then hex rings plus 1. Okay, so let's see. when hex rings is 0 and r equals 0, this will still give us 1. Yeah, it's just what we wanted. Before it wouldn't have worked because that would have given us a division by 0. So yeah, I'm glad of course I caught that. And then when hex rings is 1, that means we want to have one ring in the middle of the hexagon. So when r is 0, we want this to give us 1/2. This would be 1 divided by 2, so yeah, that's perfect. And we just add that here, and the color and terrain indexes are the same. So the triangle, that is actually interesting because it depends. Because right now, okay, so right now we're having all the triangles in the hex, we're sharing vertices because they're flat, but in this new thing they won't be flat, so yeah, every vertex needs to be unique to the triangle. That makes that a little simpler actually. Although, okay, so let's take this out. So if we need, let's say that we're working on this side right now. I should have actually flipped this because this should be corner 0, but are. So if we're on this, then this would be A, and then we want to get the one clockwise. Yeah, we're gonna have to do clockwise shenanigans like always. Okay, so let's pull this lerp amount out because we're gonna have to use it twice. So this would be the far lerp value, and the near lerp value is I think it's the same thing except it actually just be r instead of r plus 1. Still need the parenthesis there. I guess it was giving me a red squiggly there because no semicolon. Okay, so yeah, so the first vertex we want to have this near lerp value because it's going to be the center one, or it'd be this one later on in a different ring. And then the second vertex is this. I can pass the far lerp value. And then the third vertex is just I just need to shift one clockwise, which we've done that a million times, so it's just add 1 and then mod 6 so we don't overflow. And unfortunately the only problem with that is that now we have to add colors once for every vertex, and same thing for the terrain, although it's not that difficult, it's just a little bit of a shame. I guess I could have even just called this add triangle instead of building this myself. Yeah, why not just do that? Yeah, we can't. I didn't call add triangle before because I was trying to share vertices, but we can't do that anymore because they will have different y values later on. That's the whole point of doing this. And we want to have a sharp corner between each. Okay, now we just call our pass in color red 3 times. And this simple thing here for the terrain index. And now I don't have to worry about making the triangle. Alright, looks good. So let's try it just leaving hex rings as 0. And it should look exactly how it did before. And it does. Now if I set hex rings to 1, which let's just do it in the asset organizer to be, that's where it will be changed later, so. Then we should get 1 ring of vertices inside the hexagon face. Okay, we do, but the triangles are messed up. Oh, that's because I only create 1 triangle. We have to do 2. Oh wait, no we don't. We don't have to do 2. Oh, right. Down here I need to subdivide these edges and create more points. Okay, so I basically did this ring, but every time we go down a ring we have to add another point at the bottom. So I'm trying to figure out what's the best way that code. Maybe I need to change my approach to when I'm looping through here. This is a long song, seems like we've been listening to it for the last 10 minutes. Alright, so yeah, if it's really, it's just if ring is greater than 0, then we need to add another corner. But we kind of like, I'm not sure. Best way to do that. I think I need to make another function. In fact, I'll just this out, back to method. Create hex fan, and I'll just change this to corner clockwise. Or no, let's not do that. I always use the A, B, corner A. Guess I should just pass the cell index instead of the cell itself. And oh yeah, and this is not needed either. Because this point will be made in the hex fan. I need this cell? Oh yeah, because I need to know it's down there. So another private void create hex and wedge or ring. Corner A, and then int ring, or instead of ring, oh no, that's fine. So I guess the point is just that when we lerp, well, we still need to lerp along the axes to get the start and end, but then on the end might actually also, well actually on both, we need to also lerp in between these two. Well, difficult. of the near lit value. Here, corner A is this. And then if we actually don't have, let's just call this R, and then I'll probably change the name. And if this ring is first ring, near corner A and B are actually identical, but how it's going to be. Because both of these would then be 0, and that would point to the center point. So technically we could save a little time here by just setting them equal, but it doesn't really make a difference. And I'm really surprised how quickly these mesh generators run anyway, so hopefully they'll stay nice and fast. So the corner A is that. Oh, except I don't skip ahead anymore. Then far corner. Switch this out. So we need to, for the outer ring, let's say if this is ring 1, then we wouldn't add anything here. But if this is ring 2, then we would add 1. So we add the ring number -1 blurps in between. Far middle points is ring -1. The number of triangles, let's count the triangles here. We have 1, 2, 3, 4, 5. But how can we drive that? So if we went one more down, want to double the points again, or do we just? No, we don't want to double. We just add one more. Don't worry, these aren't centered, but they'd be more regular on the actual mesh. So it goes 1, 3, 5, 7. Okay, so you just add 2 triangles every time, which I guess that makes sense because we add 1 point. So triangles is, how do we do this? Okay. So on 0 it's 1, on 1 it's 3, 5, 4, it's 7. Okay, so it's just the ring times 2 minus 1, I think. No, this is ring 0. So ring times 2 plus 1. 0, we got 3. And then times 2, 4 plus 1 is 5. Yes, that's right. Okay, so if I go by this num triangles, hopefully I'll be able to find a way that I can figure out these interpolation positions based on the triangle index. So on triangle 0, start here. Okay, well it depends on if the triangle is an even or odd. Maybe it'd be better if I split this up. So it'd be like, I don't know how I call this. guess, inward pointing triangles. The same. We have 2 here. That's the ring number +1. Then we have ring number. Gosh,
you ever have that feeling where you're not sure if you're awake or still dreaming?
So let's do out of time actually, but I like to actually at least make some of these triangles so I get all this math I've done in my head. So for these, I'll just call these outward pointing triangles. It's the ring number +1 because it increases by 1 every time. That's pretty simple. So print triangle is 0, triangle less than +1, which I could do this as triangle greater than or less than or equal to ring, but just make things simpler. And so this is create triangles with 2 points on the outer edge. Which is basically just this code. Add a triangle, except I can do. Oh, we gotta figure out which corner we're at. So we have to alert between near corner A and B. And the value is given by. Okay, this is actually pretty simple. It's just float B divided by ring +1. Because, oh no, it's just divided by ring, because when we're at the ring number we want it to be all the way to 1. Oh, except on ring 0 we'll actually get an error. Here, ring 0. Ring 0 is a special case, I guess, because there's only 1 point. Yeah, so it's ring 0, then it doesn't really matter. This 0, otherwise we'll divide. That will give us the first point. Then for a second point is one of these outer edges. We've got to alert between the far points. Far corner. And this is actually so it's T divided by ring +1, I think. So we don't have to worry about the case if ring equals 0. That up a little bit. And the next one is also just T +1 divided by ring +1. And then all this information is the same. Okay, so let's get rid of that stuff. And we'll just change this to create X and ring index A and R. Let's see what this looks like. I'm running out of time, but I hope this works because it'll make it really easy to figure out the other triangles. We get like a sawtooth. Yeah, perfect. We've got little triforces. So let's real quick test what happens if I add more rings. Hopefully everything will still work. Now we have 3 rings. Yeah, and it's still great. Right, so I'm out of time, but I really want to finish this up. So let's see if I can do this real quick. So that was actually pretty simple. So now we want to create triangles with 2 points on the near edge. And we only do this though T is less than ring, which on the first ring don't have any, and then we on ring number 1. Yeah, that's right, I think. So yeah, when ring is 0, there's nothing, and then when ring is 1, there's 1. Yeah, so that's fine. The first triangle, and I've got to go clockwise. I think I actually went counterclockwise here, but it turned out okay. I just want to make sure that I wasn't looking upside down. Oh, okay, so because I thought I went up, down like that, which would be counterclockwise, but oh well, no, because A. Okay, yeah, I was thinking of corner A wrong. Yeah, because corner A is actually here, so it does go clockwise because it starts there and goes like that. Anyway, here on T less than ring, so start on near corner A and then near corner B, and first one needed to be 0 when the ring, or yeah, 0 when the triangle is 0, and then so that would be yeah, this one. Same thing except with T plus 1, because we want it to be 1 when T is 0. And then the far corner is basically skips 1. So it needs to be 1/2 when T is 0. Thinking, right, when T equals 0 and we're on ring 1, how do we get this to 1/2? I guess, do we add 1 to each? Yeah, we do. Okay, well, let's try that and see what happens. And I think I did this counterclockwise now, actually. So it's going, yeah, that's counterclockwise, so I need to put this before the second near one. Okay, yeah, so something not right. But it has something to do with actually this one. Maybe it's not ring plus 1, is it just ring 0? Or ring just divided by ring? Yeah, I think that's actually what should happen. And we don't have to worry about division by 0 because when ring is 0, this won't even run. Yeah, I think I messed up on the math there. That makes sense because, yeah, the number of near vertices is just the ring. Okay, good. So now we have perfect tiling, and we'll be ready to do the margins next time. And they'll be pretty simple. We'll just run straight lines this way and then subdivide as many times as people want. And then for these triangles, I guess that would depend on how many subdivisions there are in the margin. So if there was one, then we'd have to turn this into a triforce. If there's two, then it would be a bit more complicated, but still doable. Then once we finish all that, I will or maybe we should check out the bump map first to see if it looks good before we go any farther. Yeah, well, I'll think about it. Let's write notes for next time. So read the height map. Let's spell that. And change vertex Y positions, and then we want to subdivide margin quads and subdivide margin triangle, and lastly we want to allow mods to specify rings subdivision numbers. And then we'll be done with that. Oh, and I should be thinking about this because it's quickly coming up. Alright, well, I had just an hour stream today, but I feel like we got some good work done. Now the hexagon faces are ready to be changed to their bumpy. Ready to be made bumpy, I guess is the way you'd say that. And we'll hopefully do that tomorrow. So thanks everybody for coming by and watching, I do appreciate it. I'll be live tomorrow, hopefully on normal time at about 8:30 Eastern. And oh, one thing I noticed is, yeah, the texture still works fine here. Oh, I guess that makes sense because the texture is based on world position, and we don't have to set the UVs. Oh yeah, I just realized that, but it's good to see. Anyway, I will upload all these videos to YouTube, so if you missed anything and you'd like to catch up, you can check them out there. Be sure to follow me here on Twitch or on Twitter if you'd like to be notified when I go live. I'll also we also have a Discord channel if you want to chat with me and other viewers during the day. We'd love to have you there. To reach any of those places, you can type YouTube, Discord, or Twitter and chat, or check out the video or channel description. All the links are there. And yeah, that's it for me. Thanks again for watching. Thanks again, Ice Boy. Everybody have a great night. Bye-bye.